Welcome back to AI and Medical Affairs Road to 2030. In this episode, we're moving from the broader conversation about AI transformation into something very practical, insight generation. Medical affairs already has access to enormous amounts of scientific information, but having information and actually being able to use it are two very different things. Natalia, when we talk about AI turning data into real insights, what exactly are we talking about?
I think the key difference is between information and intelligence. Medical affairs has never really suffered from a lack of information. We have scientific literature, Congress data, real-world evidence, insights from MSL, advisory board, investigator discussion, medical information request, competitive intelligence, and increasingly digital sources as well.
Agree. The problem is that all these sources are expanding at the same time. So the challenge is no longer simply how do we find the information. The real challenge is how do we identify what matters, understand what it means, and connect it with other signals and use it quickly enough to influence a decision. And that is where AI becomes extremely interesting for medical affairs. Because AI allows us to begin shifting from searching for information to integrating information at scale. And this slide makes the scale of the challenge quite tangible. After one major oncology congress, a team can have 500 or more new abstracts to consider. Medical affairs professionals may already spend 8 to 12 hours a week reviewing scientific literature alone. And traditionally, extracting the genuinely important signals from a large Congress could take weeks. When you put those numbers together, the problem becomes obvious.
Yes, and the critical issue is what those hours are being used for. You are taking highly trained medical affairs professionals, people with clinical, scientific, and strategic expertise, and asking them to spend huge amounts of screening and organizing information. And that's not necessarily where the highest value lies.
Because the most valuable part comes after the search. It's deciding what actually changed, what is important, what is noise, and what should we do differently because of it.
Exactly. Imagine coming back from ASCA or ESMA. There might be hundreds of abstracts potentially relevant to your disease area. You need to identify new efficacy or safety data, competitor developments, changes in treatment patterns, emerging investigator questions, possible evidence gaps. Traditionally, this requires significant amount of manual work.
And there's also a timing problem. If it takes weeks to identify the most important signal, by the time you process it, circulate it internally, and decide what to do, the scientific conversation may have already moved on.
That's why I consider this is a strategic issue, not simply an efficiency issue. AI give us an opportunity to compress that time dramatically, but the goal should not be simply let's review 500 abstracts faster. The better question is, can we recognize the five things that matter most much earlier?
This before and after slide captures the shift quite well. On the left, the traditional model is extremely familiar. Manual reading, weeks of review, information sitting in different silos, and a largely retrospective process. On the right, the model changes. AI categorizes information rapidly, summarizes the key findings, and begins connecting structured and unstructured sources. What does that actually change for the medical affairs team?
It changes where human efforts is concentrated. Let's take literature monitoring. If AI can screen, categorize, and initially summarize a large body of publications, the medical professionals doesn't have to treat every paper equally. The system can help prioritize. Then the experts spend more time on the publication that actually require deeper interpretation.
Which is important because I think people sometimes hear AI summarization and assume the idea that nobody reads paper anymore.
And that's definitely not the objective. AI should help decide where human attention is the most valuable. It should not remove scientific review. Then there is a second part, integration. Historically, we have had very different types of information sitting in the different locations.
For example, quantitative publication data in one system, and MSL's qualitative observation somewhere else, advisory board findings in a PowerPoint, and perhaps real world data in yet another platform.
Exactly. And those sources may contain related signals, but nobody sees the connection because they're reviewed independently. AI can help bring those information streams together and starts changing the nature of the question we ask. Instead of what does this publication say, we can ask, are we seeing the same scientific concern appearing across literature, MSL discussion, and advisory boards?
So the real change is not simply faster searching, it's moving towards cross source interpretation.
Yes, and once you can do that consistently, you can begin moving from reactive medical affairs towards a much more proactive model.
Which brings us to the framework. You deliberately call this a roadmap because the transition doesn't happen all at once. And I think that's an important point. There's a temptation with AI to jump straight to the most sophisticated use cases. Everyone wants predictive analytics, anticipatory insights, and real time intelligence, but you can't necessarily start there.
Exactly. There is a maturity journey, and the organizations need to build capability progressively. I see three main stages. The first is automation, second is trend detection, and third is predictive insight workflow. Each stage builds on the previous one.
So if I have poor quality, fragmented data, and weak governance, Adding a very sophisticated AI model on top doesn't magically create a mature insight organization.
No, you might simply create unreliable answers faster, and that can actually be more dangerous because sophisticated outputs can look very convincing.
That's an important point. The sophistication of the technology and the maturity of the organization are not necessarily the same thing.
Exactly, a relatively simple AI workflow that solves a real medical affairs problem reliably can create much more value than an advanced system that nobody trusts.
Let's go through the three phases. The first is automation, the foundation. And the examples here are quite practical. Literature triage and summarization, centralizing field insights, and creating dashboards across sources. So at this stage, we're primarily removing manual friction.
Yes, phase one is about making information easier to access and manage. Take literature monitoring. AI can help identify relevant publications, categorize them, summarize them, and organize them according to scientific priorities. The same can happen with Congress information.
And field insights are important here as well. A lot of organizations collect MSL insights, but the information can remain fragmented by country, team, individual, or system.
Exactly. Centralizing those insights give you much better visibility. You can start bringing together MSL feedback, advisory board discussion, and medical information questions. And dashboard can help teams see across those different streams.
At this point, though, AI isn't necessarily making strategic decisions. It's creating the infrastructure that allows the humans to make better ones.
Yes, that's exactly how I would describe phase one. The goal is efficiency, structure, and accessibility.
Phase two is where AI starts doing something qualitatively different. Now we're asking it to detect emerging scientific themes and potentially identify evidence gaps and hypotheses. Can you give us a practical example?
Imagine MSL in several countries begin hearing a similar question from clinicians. Initially, each interaction may look isolated. Then advisory board raises the same concern. At the same time, a few new publications appear addressing a related issue. AI can connect those signals and highlight that something may be emerging.
And importantly, it may detect the pattern before it's obvious to any single person because no individual is necessarily looking across all these sources simultaneously.
That's one of the most interesting capabilities. AI doesn't just analyze volume, it can analyze relationship across volume. And then we can ask whether that emerging pattern represent an evidence gap, a change in the clinical practice, a stakeholder concern, or perhaps competitive development.
So phase two is really about earlier visibility.
Yes, AI help us see scientific movement sooner, but this is also where human judgment becomes even more important, human expertise.
Because AI can tell us there's a pattern, it can't automatically tell us whether the pattern matters clinically.
Suppose AI detects a sharp increase in discussion around a particular topic. We still need a scientific expert to determine, is the source credible? Is the pattern clinically meaningful? Is it simply a temporary increase in discussion? Is it driven by one publication? Could it be any bias? And is it relevant to our medical affairs strategy?
So AI identifies the signal, the medical expert gives the signal meaning.
Exactly. That relationship is absolutely central.
Then we reach phase three, predictive workflows. And I think the term predictive needs a little explanation because we're not talking about an AI crystal ball.
Definitely not. What we mean is anticipative insight. AI continuously analyze existing signals and help the organization identify what may become strategically important next. For example, it could identify stakeholder question that is beginning to appear more frequently. It could suggest that a particular evidence gap is becoming more important. It could highlight a scientific topic that is gaining momentum.
So instead of waiting until the evidence gaps becomes a major problem, medical affairs may already be considering how to address it.
Exactly. And that can influence evidence generation priorities, scientific communication, MSL engagement, and even future research.
The slide also mentions real-time strategy updates. I think that's quite a significant shift from traditional manual medical plan.
It is. Medical strategies have traditionally been reviewed at specific intervals, but the scientific environment doesn't change according to our planning calendar. If the external landscape changes significantly, AI-enabled intelligence can help team recognize that earlier and adapt.
And ultimately, the mature stage is when insights are linked directly to decisions, not just another dashboard that everyone looks at.
Exactly. An insight only creates value when it changes something.
The next slide is important because it makes the point that none of this is simply an AI tool implementation. There are four enablers: people, processes, technology, and partnerships. And perhaps we can challenge each one briefly, starting with people.
Medical affairs team need people who combines scientific expertise with digital literacy and analytical thinking, but I don't believe everyone needs to become an AI engineer.
That's important because sometimes the AI discussion creates the impression that the future medical affairs professional is essentially a data scientist with a medical degree.
Exactly, and I don't think that's realistic or necessary. What people need is enough understanding to know how AI works, where it can add value, where it can fail, and how to critically evaluate its output. But strong therapeutic and scientific expertise remain as essential.
Then we have processes, and the slide describes structured insight to action cycles tied to decisions. I think this is where many organizations probably struggle. You can generate an insight, but what happens next?
Who receives it, who validates it, who owns the decision, what action could it trigger. Without that mechanism, you can build a very sophisticated insight engine that simply produce better reports.
Which isn't transformation.
No, it's automation of reporting.
Then technology. NLP engines, real world evidence analytics, integrated platforms. Obviously, these are becoming more increasingly powerful. But the warning at the bottom of the slide may actually be the most important part. Don't buy the platform before defining the question.
Organizations sometimes start with, we need an AI platform. I would start with, what problem are we trying to solve? Maybe the problem is Congress intelligence. Maybe it is field and site integration. Maybe it's evidence gap identification. Maybe it's faster literature surveillance. The technology should follow the use case.
And finally, partnerships. There's a tendency to assume that organizations need to develop all these capabilities internally, but that's probably neither necessary nor realistic.
I agree. External partners can provide specialist scientific expertise, data, AI capabilities, technology platform, or digital expertise. And the technology is developing so quickly that strong partnership can help organizations move much faster. The key is to make sure those external capabilities integrate with internal medical affairs strategy rather than operate as separate technology project.
This may be my favorite slide because it forces a difficult question. How do we know whether we're actually generating good insights? Medical affairs has historically been very comfortable measuring activity. Number of publications reviewed, number of MSL interactions, number of reports produced, but none of those metrics necessarily tell us whether the insight was useful.
Exactly. Volume metrics are easy to measure. Impact is harder. But if we are serious about insight generation, we have to move towards quality metrics.
And you highlight four. First, relevance and timeliness. An insight may be scientifically correct, but still have very little value if it arrives after the decision.
Yes, timing is a part of quality. A valuable insight arrives while there is still an opportunity to act.
Second, influence on scientific or strategic decisions. Did this insight actually change something?
Exactly. Maybe it changed the scientific communication strategy. Maybe it identified new evidence need. Maybe it changed the question MSL were asked to explore. Maybe it influenced an advisory board or research priority. Those are much more meaningful outcomes than simply counting the number of insights generated.
Third is alignment with real evidence needs. And then fourth is something organizations sometimes neglect, continuous feedback from the people using the insights.
Yes, we need to ask users, was it helpful? Was it relevant? Did it arrive at the right time? What decision did it support? That feedback should then improve the next insight cycle.
So instead of a one way pipeline, data in, report out, we create a feedback loop.
Exactly, and I think the quote on the slide summarizes it well. A valuable insight is the one that arrives in time to shape a decision and address scientific question.
And I also like the practical 5 second test at the bottom. If the person receiving your insight can't explain the main takeaway in 5 seconds, you may have produced an excellent analysis, but perhaps not yet an actionable insight.
If it requires 10 minutes of explanation before anyone knows what matters, we still have work to do.
So we've gone from the problem of information overload through automation and trend decision all the way to predictive workflows. And when you put it all together, the message on this final slide is quite simple. The future belongs to teams that turn data into intelligence and intelligence into action.
Yes, because having the most data is not going to be the differentiator. Everyone will have access to enormous amount of data. The differentiator will how well organization can interpret it.
And how quickly they can connect the right insight to the right decision.
Exactly. AI gives us the tools to process and connect information at a scale that would simply be impossible manually. But success still depends on scientific expertise, governance, processes, and the organization's ability to act.
So perhaps the final question for the audience is the one on the slide. Where does your team sit today on this three-phase roadmap? Are you primarily automating manual work? Are you beginning to detect trends across different scientific sources? Or are you already experimenting with predictive workflows?
And I would add the second question. What is the single barrier stopping you from moving to the next stage? Because in many cases, the answer isn't technology. It might be fragmented data, it might be governments, it might be skills, it might be processes, or it might be simply that nobody has clearly defined the decision the AI system is supposed to improve.
And perhaps that's the most important place to begin. Not with which AI platform should we buy, but with which medical affairs decision do we want to make better.
That's where meaningful AI transformation starts.
I think that's the perfect place to finish. Natalia, thank you. And thank you for joining us for episode 3 of AI in Medical Affairs Road to 2030. If this conversation was useful, please subscribe to the MphaR YouTube channel. New episodes twice a month. And if you want to learn more about how medical affairs turn data into real insights, visit mphar.com. That's m-phar.com. See you in the next episode.